right, so Dakota, I am going to, let's see, I'm going to make you a co-host. That should allow you to go ahead and ask to share the screen on your device.
Okay. Is that good?
Not seeing it sharing yet, actually. There we go. I've got you spotlighted. I think that should do it.
Okay.
Everyone's seeing them big and clear?
Yep.
Okay, great. All right, Terry, I think we're good to go.
All right. Well, welcome to our museum. My name is Terry Miller. I'm the curator here. Hopefully you've met Dakota already, who's doing an excellent camera work here. So I'm going to tell you a little bit about the museum, a little background about us, and then we'll actually start looking at some of the exhibits that we have in the museum. So the museum has actually been around in one shape or form for probably around 20 years. Joe Martin founded the museum. He started it as strictly an online museum. He collected pictures, information about lots of the different exhibits you'll see here in the museum, and just took photos of them. And basically it was a photo collage with information. And then he actually started a physical museum at the Shoreline factory. He owned the Shoreline company, and we'll talk a little bit about that in a minute. And he set aside a space in the factory where he could exhibit different builders' creations. And Joe saw this as art, mechanical art. 95% of what you see in the museum was actually designed and built to actually work. And we will be having an opportunity to demonstrate some of those things for you today. When Joe outgrew the factory, the museum outgrew the factory, Joe bought this building for us. So you can see what we have here. It's about 16,000 square feet of building, and we've got probably about 10,000 of that is for display. And I've got over 1,500 exhibits here at the museum. And with that, we'll start looking around. We're going to start over here with our display of Joe Martin. So again, Joe Martin established the museum. He saw this as artwork, and he realized that none of the work that was being displayed, that's being displayed here, was available for the public. Most of what you see here today was in somebody's garage or shop in a box, and they'd take it out once in a while and show somebody, maybe take it to a trade show, that type of thing, and that'd be about it. So the Shoreline company made the equipment you see down here on the bottom. That's a small tabletop milling machine. And over to the right, you'll see a small tabletop lathe. And this is how Joe got involved with this. He started to see the things that people were making with this kind of equipment, and he was quite amazed. So that's a little bit about our history and the legacy of Joe Martin. And with that, we're going to move into the museum proper. We're going to walk by. This is a Capitol building that was built. Took about 2 years to build that. And then we're going to walk over into what we call our dollhouse section, but it's really fine woodworking, architectural models, that type of thing. And we're really going to look at just a couple things here. One is we're going to take a look at some music boxes. This is a guy's life's work in building music boxes. He started his work building small toys that he gave to different nonprofits for donations for Christmas toys and that type of thing. And then he wanted to do something more challenging, so he started making these music boxes. This is one of his more recent creations. All of these music boxes in this display case work. They're just on a set of timers so that they all run at different times because they all play music. So you don't want everything running at the same time. So you can see these online. We do have some video online of these, so you can take some more time and see them all work. As we're going to move out to another section. Here's some more of the doll houses. We've done a lot with lighting on these because typically doll houses are pretty dark, and they're made as, you know, small display things for in the home and that type of thing. Whereas we've taken the effort to actually provide a lot of additional lighting so you can see the detail that's going on the inside. And with that, we're gonna work our way over to our Duesenerg. I do want to point out we have a well-stocked library here, where we have different magazines and periodicals and other documentation related to miniature model making here in our library. We will come back to our Young Park aircraft in a minute, but first I want to show you our 1932 Duesenberg. This is one of our featured exhibits. This is model making on steroids. This is a 1932 Duesenberg. It's got a running 8-cylinder double overhead cam engine. It's got a working 3-speed transmission. It's got differential, steering, electrical, all the major components from the original Duesenberg are here. It took 20,000 hours to build it. That's 10 years, 8 to 5, 5 days a week. And when Louis Chenot, who built this, took on this task, he did it as a retirement project, and he actually did it just like his new job. He worked 5 days a week, 8 to 5 for 10 years, doing the research, development, and building of the Duesenberg. Next to the Duesenberg, we're going to look at some of the tooling that was involved in order to build the different pieces of the Duesenberg. He had to make some tooling. So for example, to make the fenders, he had to carve those out of wood first, and then he used a hammer technique to shape all the sheet metal. This is an example of one of the cowlings that he didn't use in the actual model. And rotate around here, we do, if you visit the museum, we try to provide a lot of documentation. So for example, we have photographs of all the Duesenberg in process working. And I did want to point out, even down to the actual mechanisms for the door locks and such, that's the level of detail that Louis went to. There's over 6,000 individually handcrafted parts that go into the making of the Duesenberg. All right, we're going to walk over here and we're going to take a look at our Hallbrook lathe. This is a 1/6 scale model. And there's a backstory on almost everything that's in our museum. This model came from Great Britain. The gentleman who built this actually was, at the time he started it, he was an apprentice at the Hallbrook Tool Company. He worked on this only in his spare time at his job site, wherever that would be. So it took him many, many years. In fact, he didn't finish this until he was in his 70s. So he started it when he was an apprentice and finished it in his retirement. And when his son inherited the mill, and it, by the way, it's a working mill. So if you actually applied power to it, turn it on, you could actually turn parts on it and make parts with it. His son inherited it. He approached the Hallbrook Tool Company, which still exists, and offered it to them, and they were not interested. We were shocked to find that out, and he was as well. A few years later, he heard about us. He approached us with it, and it was like, we're very excited to get this in. We've had this now for a couple of years. Really, really nice piece of craftsmanship developed by one person. Next to that, we're going to look at our Young Park aircraft. Young Park was a retired dentist, and he'd always had a passion for airplanes. And in his retirement, he decided to get the engineering drawings and actually build these aircraft. And when I first saw these aircraft, I thought it's all aluminum. And I thought he must have done a lot of research on different materials, exotic materials, that type of thing. And actually, when he started this project, he went down to Home Depot and he bought aluminum roof flashing, and that was his material of choice for building these aircraft. So we have two aircraft here. And then, of course, we have this. this aircraft here, now this one is done in sub-assemblies. So again, just like the engineering drawings, he would take and build this according to engineering drawings. And this is the sub-assemblies that would have come together in the actual factory. So some of our featured exhibits. Otherwise, we're going to just cruise around here. And if anybody has any questions at all about anything, feel free to ask. We've got working steamrollers. These, a lot of these, like I said, 90–95% of what you see in the museum was actually designed and built to work. This is an example of a working steam engine. We've got some more down here. We're going to start looking at some work that Bert Peterson did. And I always like to point this one out. Sometimes it takes a lot longer to make the tooling in order to make the parts on a model than it actually takes to make the parts. And so I point this out. This has got a cast iron seat on it for the driver. But in order to do that, Bert had to carve the seat out of wood first in order to use it as a mold. So this probably took him days, if not weeks, to make. And it's all finally carved and polished. And then, of course, it was used to make the casting, which the casting probably took an hour or something like that to actually make. So that's just an example of the work that goes into the preparation for making some of the parts. I'm going to demonstrate to you one of our working music boxes. This Calliope was built by Bert Peterson, and it uses punch tape, punch paper to control the music. So we're going to play a little bit of this. There you go. There's some music for you today. We're going to just kind of scan along here. Bert Peterson was very prolific. He made hundreds of different projects in his lifetime. 150 of those were in miniature. So this wall and this general area is all dedicated to his life's work in miniature. I do also want to point out a case steam tractor. Again, this is a working tractor. It has everything you need. You would put firewood into the firebox, and it would be filled with water. When it generated enough steam, you'd actually have the engine running. You have a clutch. You have the gear shift. He would take this to different events around town, county fairs, that type of thing. Start it up, run it, put it in gear. And then it has steering as well. And he would walk around next to his steam engine tractor and demonstrate how steam engines work. Finishing up with some of Bert Peterson's work. This is a merry-go-round that he built. So we have a few toys of his that actually work. And this one he built, he wanted something where it could include his entire family. So that's all the pictures that are around the top of it. Next to it, if I can get it working, we're going to look at some other toys that he made. And it has a motion sensor on it, which today, here we go. So these are different toys, and one thing about Bert Peterson's toys is he left the insides open, so young people, individuals can actually look on the inside and see how everything works on all of his toys. Over here we have a shoemaker, a cobbler. And it had a little different, more like an animation. So it was a little more challenging piece to put together and make it work. Now, these were all separate toys that you could hand crank. And we used to demonstrate them that way. But during the pandemic, we couldn't have a bunch of people gathered around and handling stuff. So we automated this with a drive shaft. we're able to hook everything up and make it run automatically for people to watch. All right.
Dakota, I have a question real quick.
Yeah.
So that was Burke Peterson. What did he do for a living? Like, what was his actual trade?
As I recall, and I should know this, as I recall, he was a foreman at a manufacturing factory of some kind.
So these toys were a hobby for him.
Yes, everything he did. Yes, everything we have on display was a hobby. And as I mentioned, he made hundreds of different things. So he would do all kinds of things. He would have yard art, and it was all motion type stuff. One of the interesting stories, when his family comes by sometimes, he passed away several years ago, his family will come by occasionally. One of the interesting stories that he provided, or they provided, was his grandkids came to him and they wanted a can crusher. Now, for me, I tell my kids, put them on the floor and stomp on them with their feet. That was too simple for Burke. He actually made a contraption that would load cans in. You turned a wheel, they would feed into a crushing mechanism. They would crush the cans, they drop out into a bucket, and then they keep cranking it. The next can would roll in. So that was Burke's approach to everything. He also had all kinds of collections, and he wouldn't just have them in a drawer. He would make fancy display cases. I mean, the guy was very prolific. I don't know how he had a chance to do anything else. His steam tractor, we have a steam shovel over here. He always would keep candy handy. So the neighborhood kids would come in and he would start up his steam shovel and then load candy in there, and they'd hold their bag underneath it, and then they could get candy from Burke. So he was also involved in Boy Scouts and lots of different stuff. So I don't know if he ever slept, but because he was extremely busy a lot of time.
Very cool. Thank you.
You bet. All right, we're just gonna kind of pan some things here. I'm planning on being able to go into our machine shop and demonstrate some engines for you. So as Dakota takes, he's just gonna scan some of the items here for you. If you have any questions, let us know. And I'm gonna go check and make sure we're on track for doing our demonstration. All right, so we're on track. I do want to show you one more of the music boxes we talked about. This is one of my favorite. It looks like a toolbox. It's not. It's actually a music box. And when he builds his pieces, he uses a lot of off the shelf pieces, like all the animation up here. But he made this toolbox from scratch. He would take and buy all the hardware necessary for the hinges and that kind of thing. And then he would do all the woodworking. So if you open this up, you can see inside of it, it's got amplifiers in it for the music. It's got motors in it for all the mechanism, power supplies for the lights, and all of that on the inside of it. It's just another demonstration of the quality of craftsmanship that he puts into it. Down here are a couple of the toys that he used to make that he would provide for kids, for nonprofits to distribute to different kids in the community. His music boxes used to be all over San Diego. His wife started complaining that if something happened to him, she wouldn't know what to do with them. And so that's when he was looking for a permanent home, and he contacted us, and it was like, it's just amazing pieces of art, and we're very fortunate to have them in our museum. All right, so we're going to go over into our machine shop, and Dave Bell is our master machinist, and he is going to demonstrate some of the engines that we have here in the museum. All right, this is Dave Belt, and I'm going to turn it over to Dave. He's going to do some engine display for you.
All right, well, we can start here. We'll run this little replica of a sawmill that was found up in Oregon. The blade on this sawmill in full size is about 6 foot in diameter. It's a sawmill for cutting firewood. It's run by a little hit and miss engine. And we'll see if we can get her started there. This is how they would actually cut the wood off. There's a firewood. Right, this engine runs on regular gasoline. We use coal mill gas. Over here, we'll talk about an engine. This is a Stirling engine, been around 1840. It's a heat engine. It's fully contained. There's no intake or exhaust with this engine. We heat the air in this chamber. We cool it in this chamber. As the piston comes back, it allows the air to vent through a port into a second piston or cylinder called the displacer cylinder. That's going to push the air back over to be reheated, and that air is just going to go back and forth, being heated, cooled, heated, cooled. And from that, we're going to get motion. 1840, that's old technology, and believe it or not, we're still using Stirling engines today in a much more sophisticated configuration. Let's go over here to this engine. This is an engine also from the 1800s. It is a hit and miss engine. It's a single cylinder engine. The piston travels horizontally back and forth. Through a connecting rod, it's connected to a crankshaft on which we have two very heavy cast iron flywheels. Once we get those flywheels spinning, that's going to generate energy. We're going to use a belt here to run whatever equipment we want to run. Now, these engines were used for pumping water, pumping oil. They were used on farms, and they came in all different sizes. There's one over at the Gas and Steam Engine Museum in Vista. It's very large. It's about 18 feet in length. This engine is unusual in the sense it does not have a spark plug. We do have a battery. This device takes care of that. This controls a set of contact points inside the cylinder. So in the position it's in right now, those contact points are closed. In this position, the contact points are open. So when they're closed, the engine does not fire. When they're open, that creates a gap. The spark jumps that gap, and that creates a spark to ignite the fuel, drive the piston back. We'll turn on our fuel, turn on our battery, and here we go.
The engine could go by a government and put a load on it so it slow down. It's going to fire more often. It's trying to get that RPM up to the top of speed. All right. Well, thank you, Dave. And yeah, we're gonna walk around the shop a little bit, and we'll show you some of the equipment we have. So we don't have any CNC equipment. We do have some digital readouts to help with precision, but we have a couple different mills. Dave, did you want to?
These are both vertical D mills. They're both bridge boards. This one goes back into the 60s. This one is from the 70s. This one is a little more up to date, if you will. We do have a limited computer control on this one. It's known as MDI, manual data input, and there are certain canned programs for doing bolt holes and angles and X and Y movement, if you will. Run back here. We have a surface grinder. Wire Schultz surface grinder. It's a 612 surface grinder. This machine right here is a lettering pantograph. We actually don't use it very often because we can do things on the computerized equipment much more efficiently. But back in the day, back into the 50s and 60s, this was the technology for doing engraving of lettering. This is a ram or sinker EDM machine. That's electrical discharge machine. This is again older technology. This is from dates back into the 60s. It's a spark erosion process, a very infinitely controlled spark erosion process. I mean, you can hold tolerances down into the tenths of a thousandths of an inch on machine, and you can also machine hardened material. These became very popular back in the 60s with the advent of aerospace, for machining aerospace materials, which are high nickel, high chromium content to withstand the heat. So you need that type of technology. Here's a very simple dual bandsaw. Right now, one of the guys are cutting off some brass rod, which we're making a item out of. This is another pantograph. This again was prior to CNC. You made a pattern at a scale factor that would fit your table and your part, and then you set up a scaling measurement, if you will, on 3 arms here. So if you're going to make a 4:1 scale, you make your pattern 4 times whatever your part is going to be, and then you set this up into a ratio of 4:1 on each of the arms. And as you go around here tracing your pattern, you're replicating your pattern over here. We don't have a part piece in here right now, but that's the way that works. It's old technology, but it still works. Here we have an engine lathe, not because you machine engines on them, but they just got that name way back when they were first developed, because in that period of time, any machine that did anything was considered to be an engine. So the name has stuck with them, even though there's nothing directly related to an engine. So on this one, we could do parts up to 10 inches in diameter. This is a Harding tool room lathe, very accurate, very sought after machine. This is also considered to be a chucker because it has a chucking mechanism back here. You can just release the handle and release your part, or fold the handle forward, release your part, stick another part in there. It's not really a production machine, but it's a little quicker than having to chuck things up in a 3-joint chuck.
All right. Well, thank you, Dave.
Okay, you're welcome.
We're going to head back out on the museum floor. Thanks again, Dave.
Okay, sure.
So out here we have some steam engines that we use compressed air to run them. Of course, it's dry air, so it reduces the maintenance on them, but the principle is the same. So we have a dozen or so of these steam engines, and that particular engine you see there, that's the aircraft engine with the prop on it, they actually did build a couple experimental aircraft steam engine airplanes. You can look them up on Google, and there's some YouTube video of the aircraft flying around the airfield for test flights. But I think with that much fire, they just, on these old wooden airplanes, they decided it wasn't the safest way to go. And here we have these, all of these engines and machines were built by one guy. And we have several of them that were able to drive on compressed air. Not all steam engines are self-starting. Generally speaking, you have to have at least 2 cylinders with a steam engine for it to self-start. Otherwise, it all depends on what the position of the piston is and whether or not it'll start up when you apply pressure to it. That's why almost all steam engines have some kind of mechanism to actually start it up, kind of like our hit and miss engines as well.
Is that a Shay or a Climax locomotive?
Shay or Climax locomotive here.
Yes, I'm not a locomotive expert, but I'm told that, yes, this is a Shay locomotive, and apparently it's got a distinctive configuration.
Yep. It's beautiful.
All right, so we've got some wooden ships out here. Some of these have taken years to put together. I've got one of my wooden ships where the builder actually didn't want to buy off the shelf roping or rigging for it. So he actually built his own rope making mechanism that was a model of a European rope factory where they would actually make the rope, and he actually made all of his rigging for his ship by hand. And we got some more engines here. I'll let Dakota scan these for you. Take a look at what we got. Now, Joe Martin was very involved in model airplane flying. In fact, he and another gentleman pioneered pylon racing for model airplanes. And so he was one of the people that worked to redesign joysticks for model airplane flying, radio control airplanes. And in fact, he was invited to NASA at one point because they were having a problem with their joysticks on one of their simulators. And so he went and visited NASA and helped them redesign their joysticks for that as well.
Hey, Terry.
And we're about ready to wrap things up here. I do have some other aircraft. I don't think we pointed out. I've got a model of a Wright Flyer up here. I've got an Atlas rocket launch pad, a number of different pieces back here, but that's pretty much it with our museum. If anybody's got any questions or anything, we'd be happy to answer.
I just had one other one real quick. There was a little ad you had on one of your display cabinets that you showed me during our earlier walkthrough. It was an old ad with a young lady on it. You told me a story about. I thought that might be kind of cool for everyone, if you can think of the one I'm talking about.
Yeah, Dakota recognized it. We're gonna walk over there and we'll take a look. As we go by here, I'm also going to point out some of the radial engines we've got, and I just wanted to point out a couple things here. This is a radial engine. This engine here is a rotary engine, not to be confused with a Wankel engine, which isn't really a rotary engine. The difference between the radial engine and the rotary engine is that the radial engine, the crankshaft rotates inside and the pistons remain stationary. And the crankshaft is connected to the prop. On a rotary engine, the cylinders actually rotate around the crankshaft and the prop is connected to the block, not to the crankshaft. So if you hear the term rotary engine, that's the difference between that and a radial engine. The other thing, it's a little bit of trivia here. When you see pilots that would fly these old biplanes and such, and they'd always have a scarf on, Red Baron and his scarf and that type of thing. It wasn't a fashion statement. These things threw so much oil because of their design that they always had to have something to wipe their goggles off on a regular basis. So is this the display you were talking about?
Yeah, that's the one.
Okay, so interesting story here. The engine on the left is not a miniature engine. It's actually a drone engine that was used during World War II to fly target planes. Interestingly enough, the manufacturer of this engine wanted to do some marketing. And so they said, well, let's pull somebody off the assembly line and have them hold some of our parts and we'll take some photos of it and use that for our ad campaign. Well, as it turns out, some people in Hollywood saw the photos and they said, we should have this gal in for a test session, a screen test. And as it turns out, this is Marilyn Monroe before she had blonde hair. She actually worked at the manufacturer on the assembly line. Another little piece of trivia. Anything else we can answer for you today?
Do you guys have any of Jerry Kiefer's pieces in the museum?
Yes, Jerry Kiefer's pieces.
What?
He asked if we have any of Jerry Kiefer's pieces.
Oh yeah, Jerry Kiefer. Let's walk over here. We have quite a bit. So where? Over here. There we go. So some of these pieces are from Jerry Kiefer. I do want to point out one of our smallest pieces that we have here. I don't know how well it's showing up in the video, but I will point out that there are 3 images or 2 images here and the actual item on display. This is a 1/10,000th diameter bolt. When Jerry builds stuff, he doesn't like using anything off the shelf. He actually needed a set of these bolts to assemble the item that he was building. And in order to do that, he had to first make a die. And it took him 2 or 3 tries. I'm sorry, a tap, not a die. He had to make a tap. It took him 2 or 3 tries to get a tap that didn't break because it had to go through the whole heat treating process and all of that. And then using the tap, he then made the die that he used to thread the bolts. And then of course he had to make the wrench to tighten it. And so these are different blow-ups of that. But it's a 1/10,000th diameter bolt. And then next to it, we've got what we think is the smallest working steam engine. You hook this steam engine up to compressed air and it does run.
Yeah, I first learned about Shoreline and Jerry was up by Madison, Wisconsin, which I'm down in Chicagoland. And he invited me up to show me everything about the machines and the pluses, minuses. And I ended up buying a 2000 and a 4400 and a whole bunch of accessories. Still use them.
Nice.
I think I had heard someone else chime in with a question or started to right when Terry asked his question.
Yeah, hi, this is Elaine in California. This is sort of a nosy question, I suppose. you guys have such incredible knowledge about these machines and how they run, and I'm sure about how to take care of them. Do you have some sort of apprentice program for younger people to come in and learn all your knowledge?
We have considered it. As far as machining, unfortunately, California, like most of the country, has become such a litigious environment that we don't do any training. I know Shoreline, who has the small tools, they've considered doing training. They do have different training sessions they do throughout the year. But no, we've considered it, but it's really not an option. We do have local community colleges and schools that do come in for tours, and we do offer to answer any questions if students or anyone else needs help with something. We're always available to help.
And this is sort of a second part. You have so many machines with moving parts. Do you have like an oiler position on your staff?
Great question. Our docents, we don't run everything. We do have a number of pieces like the steam engines we showed you that we do. And our docents are trained to watch for things that need lubrication. But other than that, most of what you see in the museum was designed and built to work, and the artist or craftsman would build it, and they would actually run it, and they would video it and document it, but then they would disassemble it completely again and clean it completely and then put it back together. And most of the time, those have not been run since then. For example, like the Duesenerg, we do have YouTube videos of the engine running, but we don't run that on a regular basis. In fact, it's only been run twice before it came to the museum. Actually, once at the museum before the final assembly.
I think someone wants to see the Gatling gun.
Okay, yeah, we do have a Gatling gun. I'm sorry, I missed that. This is actually was built by a Shoreline employee, and she has a number of different models here in the museum, and it's a working Gatling gun. You put the cartridges here. It takes 22 rifle cartridges, and you crank it and it fires. And one of the interesting tidbits about a Gatling gun is, I want to point out that there's this cam here that's just a straight cam. Now, what they would do is they would replace this with one that had a groove that goes back and forth, so that as you crank this, it would actually move the barrel a couple degrees back and forth, so you got a bigger spread while you shot at the target. Little trivia. Gary Connolly used to have his own company. I think he sold it about 5 years ago, where he would build these custom engines. This is a blown engine. The blower actually works. The engine runs. You hook it up to a battery, put fuel in it, and it would start up and run. And engines like this, the one over here next to it, would run anywhere from $30,000 to $35,000. And craftsmen would buy these to go into a vehicle that they were building.
They have a good talent.
Any other questions we can answer for you?
Yeah, Dave had asked earlier, I think we didn't quite catch the name of the individual who made the very small tap and die. Was it Jerry Kiefer?
Yes.
Okay. So there you go, Dave. We did have some people join in a little late. I know we started with the Duesenerg. We got to it pretty early, so I'm wondering if maybe we could sweep it one more time just for people who may have come in after the fact. Sure don't want them to miss that.
Yeah.
Yeah, and would you like to hear a little bit about it again?
Yeah, if you wouldn't mind, might just give
No
another
problem.
quick rundown on it.
Nope. 1932 Duesenberg 1/6 scale model. It's got a working 8-cylinder inline double overhead cam engine, 3-speed transmission, differential, steering, all the major components, 20,000 hours to build it. That's 10 years, 8 to 5, 5 days a week. And that's how Louis treated this as his job. And there are YouTube videos available so you can see the engine running. And it's got over 6,000 individually handcrafted components that went into making it. Since we're here in the area, I'm going to show you another piece that was just an interesting piece that I couldn't resist. So this is a model of Formula One engine made entirely from Western Digital hard drive components. Backstory on this, the marketing people did a marketing drawing of something that might exist. They took that to one of the engineers and said, could you actually build something like this? And so the engineer, not being a car guy, went out and got a Formula One model, took a look at it, put it together, and then started tearing apart Western Digital hard drives. And it took 250 Western Digital hard drives to make this.
Very cool. There was a question about the railroad cars on top of the display cases.
Yes.
He was just curious to see a little more about them and if you had any interesting stories or history about any of that.
Yeah, I'm not a train guy. We'll go by these and give you a good look at them. They are working steam engine trains. They generally, guys that build these, they run on propane. And the propane tank goes in the coal car, and then there'll be a tube that comes off that hooks up to the propane tank, and they heat up and run.
Good morning. I'm Robert Jaquist. I have a question. Are blind people allowed to touch the models? Being totally blind, a YouTube doesn't, one screen kind of feels like the next.
I have never run into that situation. I suppose we could arrange something for some of the more robust models. Generally speaking, as you can see, almost everything we have is in a display case. But I certainly could see the point of doing that and the opportunity. If it presented itself, I'm sure I could make something happen.
Very cool. All right, did we have any other questions for Terry about anything that's on exhibit here? All right, well, Terry, did you have any closing thoughts or anything? We sure do appreciate your time and taking the time to go through all this.
Yeah, not really. We hadn't really talked about these sprint cars. For anybody that's is interested and is a gearhead, this is an interesting sprint car. So this is not a remote control car. It's an actual working sprint car with steering and everything. I did want to point out the interesting name for the engine. Most people refer to that as a Novi engine. The reality is it's a number 6. And this was named after a town that was originally built next to the railroad. When the railroad first put tracks down from the east out to the west, they would just number the different stops they had. And so this was named after one of the towns. It was the number 6 stop. And that's it. And if you guys, anybody has any other questions, they can always reach me, Terry at craftsmanshipmuseum.com. I'm happy to answer questions, supply photographs, images. And we're still working on our YouTube stuff, but we hope to have some more YouTube stuff available going forward as well.
You've had a lot of thanks in the chat as well. I just wanted to point that out for you guys. Not everyone's been talking, but people have definitely been appreciating this and your time and everything. And Dakota,
bet.
thanks for the excellent camera work as well. Definitely appreciate that.
No problem.
So real quick, before people start jumping off, I did want to point out that we do have William Robertson here, and he does have a little bit of information on the Duesenberg and some unique photos and stuff. He had a unique opportunity a few years ago to work with Louis and actually see the thing taken apart and do a little bit of troubleshooting on it. So we were going to have him maybe share some stories about that after we're finished up here. So anybody who wants to stick around for a few more minutes can join in that. So.
Fantastic. Well, thanks for visiting.
All right. Well, Terry, Dakota, thank you very much for your time. We really do appreciate it.
Yeah, thank you guys.
All right. Have a nice afternoon.
All right. Bye-bye.
Bye.
All right. So I will see about sharing my screen, and I can bring up some images for William, who was kind enough to send them over to me the other day. Before I do that, William, do you want to say anything just in general about your experience there before I bring the images up?
I've been to the museum a number of times, and in 2015 I was honored as their Craftsman of the Year. You know, a number of the people I've met, Jerry Kiefer, Louis Chenot, trying to think some of the others. I was supposed to go meet Gerald Widgrove. He had moved to Spain from England, and I had a trip planned, and he got called away by a very wealthy gentleman. And I got within short distance of his place and had to turn around. But then he passed away before I could schedule another trip to Spain, which was very frustrating. But the museum is wonderful. If you're ever out there, you definitely got to check it out. It's a really neat museum, and I highly recommend it. But years ago, I guess it was in 2010, when Lou was working on the Duesenberg, he was having some issues, as any model builder does. I mean, the first part we make is rarely the right part. So one of the problems was it has 4 valves per cylinder engine, you know, with the dual cams. And there was a problem testing the valves, and somehow he ended up wanting to have a kind of a brain session of get a bunch of guys together and sit around and, you know, that knew something about stuff and talk about things. Well, my last job before I became a model builder in 1976 was working on funny cars for ATI Racing. So I'm an old gearhead from way back, and then built models for the last 46 years. So I luckily got included in this little crowd. And he also lives in my same state, so it wasn't terribly far to go there. And we gathered at his place, and he showed us the other models that he had made. The Duesenberg is not the first model he has ever built. He's done some other amazing work. And on his retirement, as was talked about, he decided to build this car. And it is not a model of a particular Duesenberg. It is, as he referred to it, the last Duesenberg. He knew all the serial numbers. It's a car that actually never existed. And could you hold on one second real fast? It's just, we're good.
I'll go ahead and bring up the
anyway.
I'll go ahead and bring up the image if that's
Yeah,
cool.
bring the images up, and they don't have to look at me. Anyway, it's the features on the car that he would have ordered had he been ordering a Duesenberg. So the body and the color, and various other features, which makes it really cool. These are pictures that I took on that visit, and he was having trouble with the engine. So in the middle of the shop. It was on the stand that he used to take it to the various shows. And he had taken the car partially apart, and he had a very nice dedicated shop. Here you see the tire, and the tires, I mean, he pantographed into the molds, the lettering, you know, the wire wheels, amazing. I mean, this thing took 20,000 hours. It was 10 years of full-time work. And it was amazing that he had a circumstance he could do that. Here's the body as it was sitting there over on one of the workbenches, the hood and the sheet metal taken off. And all those door locks, latches work. I mean, it's an amazing piece of work. I have never seen anything quite like it, and was super privileged to have not only seen it in its finished state, but to see it in this state. You know, we all learn more from models when we look at the pieces. There's the mechanism to raise and lower the top. You know, and unlike the thing being in a museum, you know, we grab the top and open it and close it, and, you know, he'd show us, yeah, this is how smooth it works. This is, you know, so this was a very touchy-feely kind of tour of this model. And as I said, in the paintwork, everything is just spectacular. All the chrome and nickel, the leather, it was beyond belief. I've never seen anything like it. This is the clutch. It actually has a working clutch. He built a working clutch. Behind it, you can see a motor. He also built his own electric motor that fit where the clutch went, that he could operate it that way if he wanted to. Again, various ways of trying to do things. And, you know, I mean, when you build something over 10 years, your thoughts and ideas change, and naturally they did. But it was so cool to see, you know, little clutch, little, you know, all this stuff. It's just neat. Here's the transmission. It's a 3-speed transmission. And I think that might have been the most fun we had, because at some point, I think it's in the next picture, he hooked the shaft up to a cordless drill. You can see in the lower left of the picture, it's the chuck of a cordless drill. And we're operating the drill at a slow speed, shifting the gears. That was just absolutely amazing. It's, you know, one thing when you say, yes, the model works, yeah, it shifts gear. It's a whole other thing when you're wiggling that gear shift and going, oh my God, that is so cool. And feeling it go, you know, the synchronizers and all that, it's just, it was so neat. So that was a lot of fun. This is the engine. He had it sitting on his test stand, and you know, we'd studied it and figured out, you know, how to do a compression test on it, and that was quite the job of separating out the valves. And the truth is, it was so long ago, I don't remember how we did it. I should, but I don't. You know, that was an entire day filled with amazement and amazing, you know, playing with a model. And yeah, that's the cylinder head. That's from the top of the head, showing the various valve, the lifters, or the, you know, that push down on the valves, and the cam. The cam's on one side, the other side it's removed. And the ones that were open were the problematic ones that we were still playing with. Again, and just imagine machining all these parts and everything having to fit and be in scale and work. I mean, it's an amazing thing. I think it might be in the next picture. Yeah. Of all the individual pieces, the headers, this blew me away. I don't remember how many hours he said it took to silver solder this in one heat, but it was at least an hour and a half. It might have been 2.5. It had about 60 parts in it that were machined. The various tapered tubes were done in sections, and he had it all jigged up, and that was difficult because the jig would want to pull the heat away. And then he, you know, brings it up to heat the silver solder, and starts at one end and just very slowly works through, and you can't stop. You can't let it cool. You know, you just got to keep going. And to play with this part was so amazing. So amazing. And then that was a pile of engine components that were rejects. You can see a couple different designs of pistons and connecting rods. And, you know, again, the parts you see in the finished model, there was a lot more because it didn't all work, you know. When I make stuff, it doesn't always work the first time. So that was just, you know, it's like, this is the scraps over on the side of the workbench, and you're looking at that thinking, how many hundreds of hours is that, you know? So it was pretty neat. So if anyone has any questions, just ask, and you know, I'll see if my memory works and I can answer them. And you know, but that's just something I wanted to share with you about the you know, something you wouldn't have normally seen and you're not going to see in the museum.
Do you happen to remember what Louis did for a living?
I do not.
No worries. I know it sounds like you maybe only interact with him a few times, but it's just, I always find that fascinating because so many of these people didn't, you know, necessarily do something that was so directly related to this, but it was clearly that was just a passion for them and they learned these things. But like, I'm sitting there thinking, like, when you're talking about how he soldered that, I'm just trying to imagine like some of the jewelers and metalsmiths I know who couldn't have pulled that off, who'd, you know, been doing metalsmithing for years. I mean, the level of technical precision to be able to solder, you know, that whole thing in a single heat like that and not have anything slip, not have anything warp due to the heat. I mean, there's an amazing amount of proficiency there.
His workshop was 2 rooms. There was a machine room with your lathes, milling machines, that sort of thing. And then there was a back room that was a couple times that size, and the machine room was quite nice. But there was a large room that was for like the plating tanks and the plating prop. He built all that. He had the casting mechanisms to do the vulcanized tires and the heated rubber into the molds and do that. And that took up a workbench. There was his soldering station. That was another workbench. So it was pretty amazing that he had, like, no, I'm not just going to go grab this torch and grab this part and try to do this. I'm going to methodically plan this out, experiment, learn, build what I need, test it all before he did each technique, you know, and get proficient at each technique. One thing I do remember about his employment that was fascinating, taking 10 years to do this in retirement makes one wonder, where's the money come from to pay the bills and live, you know, because he was not doing any side work. He was not doing other things for people. He was 5 days a week. This is what he did from morning till dinner. And we asked him that, and the answer was fascinating, and that is they had a number of rental properties, and his wife ran the rental properties, including mowing the lawn and doing everything. She took care of the maintenance, all that, and those properties funded their, you know, their lifestyle and his ability to totally focus without interruption. And you know, because it was like, we're like looking at their yard, like, this is a good size yard. How, you know, that's X hours per mow. And it's like, nope, she does that. That's, you know, it allows me to be in the shop. And that I thought was fascinating.
Sounds like the unsung hero in all this was his wife. Geez.
Yes, I mean,
that's amazing.
Just like the, you know, Wright brothers' sister Catherine, you know, she doesn't get the credit she should. I mean, but because he couldn't have done it without her. I mean, it's that simple. I mean, how do you live and build a model that, you know, doesn't have necessarily a financial reward to it? You know?
I think it's interesting he built his own plating lab. I remember some year, quite a number of years ago, thinking I would try doing a little electroplating, and I visited a lab, a company that did it. And then when I worked at Tektronix, we had places that did that, and there are some insanely nasty chemicals in there. Some of that, I think, chrome has to be plated. My friends here will tell me if I'm wrong. I think chrome has to be plated with caustic soda or cyanide solutions, and nickel, I think, is acid. Copper is acid based, and you can't get those ever to mix, because if you do, well, you're gone, because
Yeah.
you'll
Creates hydrogen cyanide gas. Yeah.
yeah, it's very unhealthy to inhale that stuff.
Sure.
I do remember his plating operation was, I'm going to say, at least 12 feet long against the wall. And it was various sinks and baths and, you know, this and that with chemical storage cabinets. I don't know. I think he must have been planning this model on a long term and had access to, I hope he had access to surplus stores that had industrial surplus, so that he could be buying the, you know, fireproof cabinets and that sort of. I don't recall that stuff looking new. I do recall a lot of things he had repainted and reworked. You know, that they matched, the, you know, colors matched various machines, and you could tell he had clearly restored, I'm going to say, at least half the machines in his shop and had painted them. And he had done the same with cabinets and sinks, but everything was handled properly. I think there was a large vent hood over that operation and the soldering. You know, it was honestly a more professional setup than most small companies have, at least at the time. I mean, nowadays there's lots of environmental regulations and all this, and but a long time ago things were a lot looser. But he really did it upright.
That's pretty amazing. Well, I thank you, Bill, for taking the time to talk with us about this and share your unique, you know, footage of it and everything. That's really an extra little slice of life we certainly wouldn't have gotten from the museum itself. So I was really excited you were willing to join us.
Yeah, they don't have that. So.
Right.
That's
very cool.
I was tempted. I took a lot of pictures of his shop, and you know, I don't want to share those without permission. You know, the model, I know that was fair game because we had talked about that, but you know, I have lots of great shop pictures from various people's
sure
shops, and you know, it's pretty neat stuff.
Well, seeing the facilities they work in is almost as, I mean, that tells you an awful lot about the artist for sure. So it's very cool.
And some are really fancy, and others, you know, I had a friend in England that had a little shop that we wouldn't even refer to as a garden shed. We wouldn't want to put a used lawnmower in it. I mean, it had a dirt floor and a junk crooked workbench, and yet he did amazing work in there, you know, and it was crammed, and every time you moved, you banged into something that was hanging from the ceiling or whatever. And, you know, totally a mess, yet he could create great work.
All right, well, we are about 15 minutes past 1. I suppose I should probably go ahead and wrap this up. I know you're all busy, and again, sure do appreciate you taking the time to join us, and I think this was a really great session today. And so again, I'll just say real quick, thank you very much to Bill for sharing his insights to this. And yeah, somebody did mention the Museum of Toys and Miniatures in Kansas City, and yeah, that is the same Bill Robertson. If any of you are around town, you know, anytime, go check that museum out. It's an amazing place. Real quick, we have another meetup coming on June the 15th, where we're going to be looking at some Mamaki 3D printers. We got a chance to see some of their output at the APMM conference a few months ago, and it's pretty amazing multicolor print stuff that, and prices are surprisingly reasonable for some of these printers that they're offering. So if any of you are in the market, you maybe come check it out. You learn a little bit about the current state of some 3D printing industry stuff. And with that, I guess we'll go ahead and close it out. And I hope you all have a great rest of your day. We'll see you later. Thank you.
Bye-bye.
Bye-bye.